To start, I made a voltage divider to split the initial voltage of 9 volts to 4.5 volts. 9 volts would have been too much for the op amps in my transmitter to receiver design. The signal is received through a solar cell connected to a 10,000 ohm resistor to ground in a capacitor of 1 microfarad. Alternating current will go through the capacitor as it stops direct current. I made sure to add a 10,000 ohm resistor attached to the ground to allow voltage to continue to the op amp even when the solar cell doesn't have any signal from the laser. After the capacitor and resistor, the alternating current feeds into a non-inverting op amp with a gain factor of about 50. This is due to it being inputted through a potentiometer, which has a resistance ratio of about 50:1. The potentiometer output goes to a node with 200 ohms to ground and the negative input of the amplifier op amp. The first wire of the trimmer is then connected to the output of an amplifier. The potentiometer adjusts the gain factor of the current depending on its resistance level. I can change the resistance level by twisting the trimmer left or right to higher and lower the level of sound. I can change the resistance level by twisting the trimmer left or right to higher and lower the level of sound. I have the signal created after the amplifier op amp going through 3 buffers, which causes the current and power to increase. We need this so the speaker can be heard. The speaker only receives the signal when the laser is shown on the solar cell. This will cut down on unwanted background noise. The output of this amplifier goes into the input of our buffer op amps, which all output the signal. The next part is the transmitter. The aux is connected to the ground and to a 10 microfarad capacitor to the trimmer. The potentiometer is then wired to ground. The current makes its way to the negative input of a summing amplifier. It is then filtered with a combination of 10 microfarad capacitor and potentiometer connected to the ground. The mic is powered by a 4.5 volt rail with a resistor. The resistor is 10k ohms and is parallel to a 10 microfarad capacitor, which is also parallel to a 10,000 ohm resistor and another potentiometer and then another summing amplifier. The summing amplifier is grounded by its positive input and the resistor from the negative input. The output is connected to a 470 microfarad capacitor and the laser. The laser is attached to the ground with a 100 ohm resistor. The next portion of my project is the LED bridges. I use the LED bridge to represent when the transmitter or receiver was getting current. More current means more of the lights will light up. The bottom is for the receiver and the top is for the transmitter. Once the signals are higher than each of the reference voltage, the LEDs will turn on, giving the effect of light moving up and down. This happens because the output of 4.5 volts goes to the respective LED once the reference voltage has been reached.